esto, para dejarles que no digan que no estamos haciendo nada. Okay. This is the screen I want to share with you. This is the problem in your binder. So is the problem released in 2003. There's no calculator. And again, you have a graph of a function, and this function is the derivative of another function. So this is not the function f, it's f prime. You can see here at the bottom of the graph. Using the information right here, we have to answer the 4 questions next. Here says, let f be a function defined on the closed interval -3, 4 with f in 0 equals 3. So this is something you know about your original, the function you want, the function f. F in 0 is 3. The graph of f prime, the derivative of f, consists on one line segment and a semicircle as shown above. So this one, right? First question, on what intervals, if any, is f increasing? Justify your answer, okay? So, just take this one right here. And this is the point, correct? So let me just stop the sharing here and go to my board. Here is my board. So what you have here is a graph, very simple, yeah, that is a line and then a semicircle, something like this. Let's suppose that's a circle, correct? Yep. And this is f prime of x. Now the first question is f of x increasing, correct? Where f of x is increasing? This is, well, how do you know a function is increasing? This is f of x is increasing on an interval AB if f prime of x is positive on every point on this interval. So this is the definition you have to use. No calculator, no big things, it's just this definition. The function is increasing when the derivative is positive. It's increasing on an interval if on every point on this interval the derivative is positive. Okay, now you see the graph. Now this is the derivative, correct? This is the derivative, right? Now this is the x-axis, this is the y-axis, correct? So f prime positive in this section of the quadrant and f prime is negative right here. So this point is -3, this is -2. So where the function is increasing?
-3 to -2.
Exactly. So this is f prime of x positive on -3, -2, this interval. Then f of x increasing on -3, -2, correct? Aquí pueden poner from graph. From graph, f prime is positive on -2, then f prime is increasing on -3, 2. Not difficult, right? Very simple. Okay, let's see now.
¿Cuál era el problema otra vez? Era el...
Problem, aquí te lo voy a enseñar. So, is this one? Is problem in page,
okay, sí.
in page 3?
Page 3, yeah.
Page 3.
I was looking at the one in the back.
Page 3. Okay, well, now, we answer question A. Now we're going to answer question B, correct? This one. So, this is, find the x-coordinate of each point of inflection of the graph of f on the open interval at -3, -4, and a +4. Justify your answer. So on all this interval, -3 to -3 to +4, right? We have to find the inflection point. Okay, let's see. So I'm going to go back to my screen with my approximate graph. So this is -4, that's +4, -3, and this is f prime of x, correct? Again. So what is the criteria to know the inflection points, right? So because said, find the inflection points of the graph. What is the definition of an inflection point? Do you remember that? So this is the
When
first
the
thing.
derivative is 0.
Which one?
When the derivative is 0.
The derivative is 0, yes, but more important, yeah?
There's no peak, sino como un, o
No,
como.
you need something else.
Oh.
Yeah, you need something else.
It goes through the x-axis.
Okay, this is the point, correct? So let me just use a function like this, right? Yep. So you have here a max, you have here a mean, correct? You have a concavity here, and you have another concavity here. So there is a point here, and that is the inflection point, the IP, inflection point. The inflection point is where the concavity change, right? So
Yep.
it's between a max or a mean, at least one between them, correct? So what is the definition of inflection point? F of x has an inflection point at x0, let's suppose that's x0, if the second derivative in x0 is 0 or undefined, correct? So this is the definition. The second derivative of the function at that point is 0. Or the inflection point are the values that solve the second derivative to 0, or the second derivative is undefined, so you have a peak, correct? Now, using this definition, watch this graph. Where the function, the second derivative, where the slope of this, remember, the second derivative is the derivative of the first derivative. So the second derivative give me the slope of the tangents for the first derivative. So I'm going to put here, f double prime of x is the slope of tangents to f prime of x, correct? So f prime of x equals 0 is horizontal tangents of f prime of x, correct? Let me just put this better. For f prime of x. Okay, if you watch this graph or you watch the graph on the paper, where do you have horizontal tangents for this one?
Peak?
No, in the peak, you have no tangent.
Well, like close to the peak.
Okay, a ver. This is a circle. You have a tangent horizontal? Yes, right here.
Oh,
In 2, you have a tangent that is horizontal. Now,
I was
the
thinking
next
vertical.
one is this one, where the f prime is undefined. Yeah, where f double prime is undefined. So here the slope is negative, I guess is negative, what is negative 1? Yeah, it's negative 1. No, negative 4/3. No, negative 1. This slope is negative 1. Here the slope change is 0 and is negative. Here the tangent does not exist, you see? So you have f prime of x equals 0 at x equals 2. f double prime of x undefined at x equals 0. Right? So my inflection points, IPs at x equals 2, x equals 0.
Can you explain that again really quickly? What's that?
Wait, what? What portion?
Why the inflection points are there?
Okay, again. The inflection point is where the second derivative is equal 0, correct? This is the definition. The
Yeah.
function f has an inflection point at x equals 0 if the second derivative is 0 or undefined at this point. Okay. The second derivative is the derivative of the first derivative, correct? So the second derivative is the derivative of this. So
Yep.
if you want the second derivative equals 0, that means that this has horizontal tangents in this point. So f double prime equals 0 are the horizontal tangents of f prime. Now, if you watch the graph, where you have a horizontal tangent, not here, this tangent is -1. Right here,
At x
you don't
equals
have a
2.
tangent, it's undefined. So you have this criteria. This is a circle, so you have a horizontal tangent in 2. So you have this criteria. So f double prime equals 0 are horizontal tangents for f prime. So in 2, you have a horizontal tangent for f prime. So my conclusion, f double prime of x0 at x equals 2 is this point. F double prime undefined at x equals 0 is this point that you have no tangent. So my inflection points are in 2 and 0.
And I have another question. So what if the graph, like say it was just like f, normal f, and it was asking for the derivative of that, or for the inflection points there? Would it be the same thing?
It's like this red. So if you have the graph, you can see the concavities. You can check pretty much where the concavity change. Here is concave down. There is a point the concavity change, concave up. So here is an inflection point. Right here, you see the concavity change also, right? Concave up, then concave down, you see? Here is another inflection point. So from the graph, you pretty much by simple appreciation or visually, you can determine the inflection points. If you have the function, you have to take the second derivative and solve to 0. Okay? So, but in the graph, if you see a concavity change, a point between the max and the mean, pretty much where the concavity change, that's the inflection point, you see? Right here.
Yeah.
So graphically, and if you have the function, you have to solve the second derivative to 0. Okay? Well, next question, right here. You have this, find an equation for the line tangent to the graph of f at the point 0, 3. So, okay, let's see what is the point of f 0, 3. It's okay, let's see. This is the point. You see here, this find the coordinate of each point. No, this find an equation for the line tangent to the graph at the point 0, 3. Okay, let's see. 0, 3. You see here the point 0, 3. That's a point on the function, correct? Now, I want to know how is pretty much the tangent line, correct? So let me just write this one. Let me just put here an example before we move to this problem, right? So I have here a function, this is fx. Okay, right here, let me just recall the situation, right? So here you have the graph of a function fx, correct? This is the y, this is the x, right? And, okay, So if you want, for instance, the slope of the tangent line at this point. So it's okay. This is the function x0, the point x0, and this is the point x0 comma f of x0, right? That's the point, this one right there. Now, the slope of the tangent line, so you need y minus y0 equals mx minus x0. So this is the slope of any straight line. So what you need for the equation, you need a point the line passed through and the slope. Okay, the point is right here. x0, y0 is x0, f of x0. So this is the point. And the slope of the line is the derivative f prime in x0. Okay? So this is the way you solve this problem. You have a function f. You need the equation of the tangent line at a point on the function graphs. Then if you have x0, the point is x0, fx0. This is the point. You want the tangent there. You want the equation of the tangent line. Okay. So this is the equation of any straight line. You need a point, the line passed through, and you need the slope of the line. Okay, the point is this one. X0, y0 is x0 of x0. And the slope is the derivative of the function evaluated at the point x0. Is what you have to do. Now, you need exactly the same for the line. So you need, you know, the point is 0, 3. So this is 0, f of 0, correct? Check the problem. Let me just go to the problem right here. You see, f of 0 is 3, and the point is 0, 3. You see here the point, 0, 3, f of 0, 3, so that's the point. Now, you need f prime in 0, correct? Now, you have this graph. This is the graph of f prime. How much is f prime in 0?
-2.
-2. So my point is 0, 3, my slope is -2. So I go to my paper. So 0, 3 is f0 f of 0. F prime of 0 is -2. So I have the point and I have the slope. So y minus y0, 3 equals -2. That's the slope, right? X minus 0. That's my equation. Okay? So you don't have really to do any complex operation. What you need, your algebra, this one, the equation of a line, point slope. Once you have this one, you have to identify who's the point, who's the slope. The point is a function on the graph. It's a point on the function of the graph, this one. Then you identify. The slope of the line is the slope of the tangent line. Who gives you the slopes of the tangent lines? The derivative. So you take the derivative and you evaluate in x0. That's the slope of the point here. This is the slope of the tangent line at this point. Once you have those ones, you just plug them in the equation and you have your answer. You don't have to change anything here. This is the equation of the tangent line. They are not asking you put in the y-intercept or standard form. So this is the equation. So stop there. You possibly mess up in the algebra. So don't take any risk. This is good. No questions? Everybody fine?
No.
Okay, let me see. Oh my gosh. Okay, let's see. Next question. V. Find f of -3 and f of 4. Show the word that leads to your answer. Okay, yeah. Here is a point that is going to be important because now you have to get values of the function without know the function. So you have f of -3, you see at the bottom. You need to find f of 4, right? And the only you know is f in 0 is 3. It's the only thing you know, correct? So let me just stop share. So this is what you have to solve. F of -3, f in 4, and the only you know is this one. Okay, well, remember what is f prime. F prime of x is the derivative of f respect x. So this is the definition of f prime, correct? Not a big deal. Now, this is the equation that relates f prime with f. You see? Now I need this f, and this f is inside the derivative. So I have to take the integral. Integral from df dx, correct? And I'm going to put here dx is the integral of f prime of x dx. So to undo the integral, I have to do the derivative, I have to use the integral. So everybody understand this step? So I need to cancel this derivative to get the function free. So I have to use this one. So this is the integral of df. This is the integral of f prime of x dx. Now, what is the information you have? This one. In 0 is 3. Okay. In 0, the function is 3, or f of 0, right? And I have here f of x, right? And here I have x. So I'm going to put here an x and a 0. So I am abusing the notation because usually this x is going to be a different variable, but I don't care as much as you understand the thing. Now, this differential is going to be f of x minus f of 0. So this cancels this, so you evaluate this f in fx and this f in 0. And this is going to be the integral from 0 to x, f prime of, well, if you want to be consistent, we change the variable of integration, we put fs ds. Now, everybody's understanding this procedure. This procedure is going to be very used in these problems. So f of x is going to be f of 0 plus the integral from 0 to x, f prime of x, the f prime of s ds. So I'm solving a differential equation. We're going to solve more differential equations later, but this is the way we undo a derivative with the integral.
Where did the SDS come from?
Because in the books, they don't want you to use the same variable you have here in the limit of integration. So I changed this x by ds. It's a
Okay.
use substitution, no problem. Okay?
Mm-hmm.
Just to be consistent with the books. Okay. Now, this is 3, correct? Plus area between 0 and x. So everybody understand this? The f of x is going to be given by the value of f in 0, that is a 3, is right here. You see the 3. So it's a 3. And the integral is the area between 0 and 2 and the function f. Is the area under the line of this graph between 0 and x. So what I have to check here is the area. Let me just share the screen. Here, you see the area under these curves, right? So let me just go back to my board. So what I have to do is, let me just sketch quickly the graph. So I have my graph, I have my line, I have my circle. So I have to check this area, this area, this area, and this area, the portion right here. So that's the value I have to use, correct? So everybody understand this portion? So let me just go back here. Let me just move the board a little bit to the right. And now I have to get f of -3. So it's going to be is going to be 3 plus the integral from 0 to -3 of f prime of SDS. Correct? Now, I have to uh, solve this area. So is the area between 0 and -3. So is this portion right here and this portion right here. But now you see the 0 and the 3. What happened with these two numbers? A ver, Leo. -3 and 0. Are they in the correct position?
No.
No. So I have to do 3 minus integral from -3 to 0 f prime of s ds. Correct?
Mhm.
Now, this area, let's go to the problem. Okay. How much is this area of this triangle? This triangle
One.
at the top, right here.
Wait. 1/2.
1/2, 0.5. How much is the area of this triangle right here?
1. Wait, no. 2. 2.
2 times 2 divided by 2, that's a 2. So this is positive and this is negative, correct? This is 0.5 minus plus negative 2. So it's what I'm going to put here. So this is 3 minus parentheses 0.5 minus 2, correct? The area of the first triangle above the axis, the area of the triangle below the axis. Remember, all the areas below the axis, these ones are negatives, correct? These ones are positives. Entonces, ¿cuánto me queda? How much is that? 3 minus 1.5.
1.5.
So is 1.5, correct?
Mhm.
Okay. Now you are going to get the area or the value of the function in 4. What is the value of the function in 4? Okay. So I have to put here a 4 and I have to put here a 4. Correct? So I'm going to write that. So f of 4 is 3 plus the integral from 0 to 4 f prime of s ds. Okay, Areli, are you there?
Yeah.
Okay. Now, are these limits of integration fine? What do you think? From 0 to 4.
Yeah.
Okay, you don't have to switch anything. This is the area between 0 and 4 on this graph. Okay, vamos a ver. Let's see this. Okay, I need the area in this section. So I need this little portion right here, and I need this little portion right here from 0 to 4. I don't need this rectangle. I need just this portion and this portion above the circle and between the axes. How do you find that area?
Well, couldn't you find the area of the rectangle and then subtract like the half circle?
Correct. Very good. So that's what I'm going to do. The radius of this circle is 2 and it's half. So it's going to be, okay, the area of the rectangle is 4 by 2. So that's a
8.
8, correct. So it's going to be minus, I'm going to put here 8 minus, okay, I'm going to put here, this is pi radius square, is pi to a square divided by 2. So this is what you're going to see on the board, correct? So this is the section between the rectangle and the circle. So the area of the rectangle is 8. I'm going to put a minus. Why? Because this is below the axis, so the area is negative. But I'm going to subtract this one. Pi radius squared, the radius is 2. Pi radius squared divided by 2. So I'm going to do now my numbers. So it's 3 minus 8 minus 4 divided by 2 is 2. So it's just 2 pi. Correct? And now I just subtract the like terms. It's 3 minus 8 minus plus 2. So it's 2 pi minus 5. Correct? Remember that there is no calculator to do the 2 pi and the decimals. Obviously, you can approach 2.14, but don't worry. You can answer in terms of pi. Okay? Everybody? Okay.
Mhm.
No questions about this procedure, how to get the
How do you
f
do that
from
again?
the f prime?
How do you do that again?
Really?
How do you come up with the equation?
Okay, again. Let's take this one.
No, just explain it. It's good. I'm kind of lost.
Okay,
No, tiene que borrar.
so f prime is df over dx, correct? F prime is the derivative of the function respect x, right?
Okay.
The function is inside right here. Well, remember when you have a square root of x equals 3?
Mhm.
The x is inside the square root, so you have to use the inverse function, the square, both sides, correct?
Mhm.
You square the square root, you cancel, and then you get 9, correct? You solve for
Mhm.
x. Well, you have to do here the same. Because this function is inside a derivative, I have to do the inverse operation, integral. So I take the integral of the derivative of f dx, right? And I take the integral this side also, the integral of f prime dx, correct? Now, the derivative and the integral cancel, same as the root and the square cancels, correct? So I have df, the integral of the differential of x. It's like these two cancels and this cancel, correct? Then now you have to put limits. You have the function running from 0 because it's your initial condition. F in 0 is 3. So you put here in the variable x 0, and then you open the variable x, f prime of x dx. Now, this is a problem because you cannot have the same variable here and here. So you can change this by an s, but it's pretty much the same. F prime of s ds from 0 to x. And here, this cancels this, and then you have to evaluate this fx minus f on 0. So you have to take the differential of the difference of these two, is right here. Now, f of 0 is 3. So you have that the f of x is 3 plus the integral from 0 to x, f prime of s ds.
Mm.
Okay. Now, from here, you have, this is the initial condition, and this is the area. So you can go to the graph and compute this integral using the areas right here.
Mhm.
That are the areas of triangles and circles and rectangles and all that. This is what I did here, correct? The function in 4 is the 3, this 3 right here, and the area between 0 and 4. So the area between the circle and the line, right? That was a rectangle minus the half the circle. That's my answer. Okay? Everybody fine?
Última
Okay.
pregunta de esto. ¿De dónde llegó el 3?
The key.
Or where did that come from? From the
The key.
beginning?
The
And
problem.
the problem.
The problem? Okay.
This data
never
is
mind.
information from the problem.
Ramirez,
Okay.
Mm-hmm.
could you use another letter besides S?
T, Y, any other one.
Oh.
It's open. Okay. When I was in college, right?
Mhm.
And we were using this notation right here. Esta. This one. My teachers use, say, we're destroying the notation. So because this is not the standard. Use the x here, everything x. No, this has to be a different variable than this one. So when you do this, technically it's correct, but not formally. So they say destroying the notation, we do this. In physics, it's very used, this one. You destroy the notation, you don't do this change. So you get here s with x here. So it's informal, but finally it's correct. You're going to get the correct answer, okay? But let's do the things correctly. So we change the variable. You can put here a t, a s, a u, a v, a y, any variable works, correct? So not a big deal. Well, let's erase this portion right here. And let's see the problem we are going to solve. Well, we have like 10 minutes, 7 minutes for before 12. Let me just go back here and then go to the problem that is before this one. Correct? So this is the problem. It's another graph, but now this is the graph of the function, correct? not the f prime. So you see here the graph of f.
Mhm.
Okay, now, this is the graph of a differentiable function f on the closed interval negative 3 to 15 is shown in the figure above. The graph of f has horizontal tangent in x equals 6. You can see here this, correct? Here is the horizontal tangent. And
Yes.
then you define another function using this one, correct? For negative 3 at 15. So you get a new function that you have defined, use this one. You see the variable change here, ft/dt. This is a function of x, yeah? But for the integral, you define a new function, you put the x right here in the limit of integration, and the variable in the integral is different. So it's just formalism, but it's the same. Now, let's solve just the first problem. What is g of 6? What is g prime of 6? And where is g double prime of 6? Okay. Where is the 6? The 6 is right here, correct?
Mm.
Okay. So let me just write this one. G of x is 5 plus the integral from 6 to x of f of t dt, correct? Now, let me just show you this one, right? Here is my, what is blurry? Okay. Okay. So you pretty much watch this one. Okay, there is. So this is the function. Now, I want g of 6. G of 6 is 5 plus the integral from 6 to 6 ft dt, correct?
Yep.
Okay. Now, how much is this integral?
0.
Correct. Because this is a line. So
They cancel out.
no cancel out. The integral from a to a of fx, from a to a to the same point, is 0 because this is a line. So if you have
It has
the
no area.
function,
Oh,
this is
okay.
a, the area of a line is 0, correct?
Yeah.
So that's why this is 0. So 5 plus 0, 5. So ya tienen el primero. G of 6 is 5. Now, you want G prime of 6, correct?
Yep.
It's okay. Let's go back
See it.
to this portion right here. So you want G prime of 6. Okay, let me see. So let me just go back to my board. Stop share. And this is 5 plus, bueno, no 5. So le voy a poner aquí un 6. G prime of x is the derivative respect x of 5 plus the integral from 6 to x ft dt, correct? You have to take the derivative of the 5. What is the derivative of the 5?
0.
0. The derivative of this function, well, the
Just f of
derivative of the
t.
integral cancel, and then you put here the x. So this is g prime of x equals f of x, correct? So if you want g prime of 6, you have to watch the value of the function in 6. So
15.
let me just go back to the graph. What is the value in 6? What is the value of f in 6?
3.
3.
Right. Yeah.
So this is 3, correct? Okay. What is the next question you want? Okay, the next question they want is g double prime in 6. What is the value? Okay. Well, g double prime of x, correct? G double prime of x is the derivative of this one. You see, g prime is fx, so g double prime is f prime of x. Because this one, you see? If g prime is f, g double prime is f prime, correct? So g double prime of 6 is the derivative in 6. What is the value of the derivative of f in 6? Let me just go
0.
back to the screen. So the slope of the tangent line to this function in 6 is 0.
0.
So my g double prime of 6 is 0. Okay. Well, tomorrow we continue with the rest of the questions for this problem.